Absolute value equations. An absolute value equation is an equation that contains an absolute value expression. To solve the absolute value equation of the form the absolute value of x minus c is equal to d, where d is greater than or equal to 0, we can write two separate equations. We can say that the expression x minus c is equal to negative d, or x minus c is equal to positive d. And this leads us to two solutions, x equals c minus d, or x equals c plus d. And we can see this visually on the number line because here's a graph of the solutions, the two red dots, where we have our center being the value of c. And if we subtract d, we go to the left. That gives us one solution on the number line. And if we add d, we move to the right, a distance d, we have a second solution. So these absolute value equations have two solutions with their center of c. The absolute value equation of the form absolute value of x minus c equals d, where d is greater than or equal to 0, has two solutions. So here's an example of how that works. Here's where c and d have numbers. We have the absolute value of x minus 2 is equal to 4. So if we look at this graphically, that means we have a center of 2, c is 2, and we're moving a distance d of 4 in both directions. We have 4 to the left, so you are subtracting 4 to go to negative 2 for one of our solutions. And we from 2 are then going to the right 4. We are going 4 to the right for positive 4. So 2 plus 4 would bring us to 6. So the solutions for that equation are negative 2 and 6. You also could solve it algebraically as well, where if you set up x minus 2 equals 4 and add 2 to both sides, we get our answer of 6. And if we set up x minus 2 is equal to negative 4, and we add 2 to both sides, we get our other answer of negative 2. So graphically, visually, or algebraically, we have two solutions. Here are two more examples. We have solving for x and graphing the solutions on a number line. We have here the absolute value of x plus 3 is equal to 5. So graphically, if we have our center, now it says plus 3, but we know that x plus 3 is really x minus negative 3, since our little formula or our format had a negative, a subtraction sign. So our center is negative 3, and we're moving a distance of 5. So 5 to the left would bring us to negative 8, and 5 to the right would bring us to 2. Algebraically, if we set up x plus 3 is equal to 5 and subtract 3, that brings us to our first solution of 2. And if we set up x plus 3 equals negative 5 and subtract 3, it brings us to our other solution of negative 8. Here we have 5 minus x equals 3. So here we have a center of 5. We can rewrite the absolute value of 5 minus x as x minus 5 equaling to 3 to put it in our correct format. So then we are having a center of 5 and moving a distance of 3 to the left to arrive at our first solution of 2, and going to the right from 5 to have our second solution of 8. Algebraically, if I have x minus 5 equals 3 and I add 5 to both sides, it arrives me to the first solution of 8. And if I have x minus 5 equals 3 and or negative 3, we did 3 on the right, now we're on the left, and I add 5, it brings me to the other solution of 2. So algebraically, or on the number line, there's your two solutions. Two different ways of thinking about it. So here, the solutions are d units to the left and to the right, of that center C. Now, what if you start out with the graph? You visually have the solutions. So here's an example where the two red dots are the solutions. We have a solution at -3 and a solution at 7. Our center is 2. We can now ask, kind of going backwards, what absolute value equation has these solutions? Well, you have a center of 2. So automatically we know our center is the absolute value of x minus c, so absolute value of x minus 2, is going to equal, well, we need d. We need the distance from the center to the solutions. Well, we have 1, 2, 3, 4, 5 to the left, and 1, 2, 3, 4, 5 to the right. So we are a distance of 5 from our center, so it will equal to 5. That absolute value equation is x minus 2 equals 5. And it has the solutions -3 and 7. Here are two more examples. Here we have a graph where the center we have is in between -1 and -2. So we can see that C is -1.5. And we have a distance of 1, 2, 3, 4.5. So that gives us an absolute value equation of the absolute value of x minus -1.5, which is the same as plus 1.5, is equal to 4.5. In F, we have a center of -4.5 and a distance of 1 to 3.5. So we have an absolute value equation of x minus -4.5, which again, we're going to rewrite as x plus 4.5 and is equal to 3.5. So our original definition of the absolute value of a number x was the distance that number x is from 0 on the number line. Well, now it's not just x anymore. We have the absolute value of a number x minus c, where it's written like this, with the 2 bars for our absolute value, is going to be the distance that the number x is from C on the number line. You're basically moving your center where your distance is going to be from. It's no longer just from your origin. This is where the absolute value is greater than or equal to 0, where it's d is a positive number. Well, distance is always non-negative anyway. But if you have the absolute value of an algebraic expression set equal to a negative number, what do you think the possible solutions will be? Well, it's even hard for me to ask that question. Can you think of a possible solution where the absolute value is set to a negative number? Even if you can think of an answer, can you prove that your answer is correct? Hopefully you're as confused or as puzzled as I was even asking the question, because if you think about it, the absolute value is that distance that a number is from C, and distance can never be negative. So distance, you can't set absolute value to a negative number. So it's not possible. You shouldn't be able to think of any solutions. Just remember about distance, and then it will come to you and you'll be set straight.